Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Baiklah, nama saya NURUL SAFINAZ NOR FAUZI, matric number J46166. Jadi pada hari ini saya ingin membuat pembentangan mengenai projek khusus bagi khusus TKP 3501, mekanisasi pertanian dan pengairan. Jadi pada hari ini saya akan membentangkan tajuk projek saya adalah Review Journal Development and Evaluation of a New Generation Oil Pump Motorized Cutter, cantas Evo. Jadi saya akan membentangkan dalam dua bahasa. Okay, introduction. Okay. Mechanization is about to improve workers' productivity, which is ultimately aimed at reducing workers' requirement in estate. It is a fact that at present the industry is really dependent on the foreign level to carry out field operations. The issue has become very critical because there are cases in estate where the harvesting round has to be extended to about once in 20 to 25 days due to insufficient workers in the plantation. Also, cases where the estate have to do early replanting even when the palms are still producing good yield because they do not have workers who can harvest tall palms despite offer of high pay. A more serious problem is that more than 90% of the harvesting operation, the core activity in the oil palm plantation, is carried out by foreign workers. Oil palm mechanization. Effort to increase workers' productivity by adopting new methods and technologies are being implemented and enhanced in the industry. There are three elements that contribute significantly to productivity of the workers: tools, work system, and labor that need to be well synergized in order to achieve optimum productivity. With the right tool, effective work system, and trained operator, maximum output can be derived. Mechanized harvesting of fresh fruit bunch. Efficient harvesting can be achieved by using efficient harvesting tool and sufficient harvester to cater to harvesting round at the recommended 10 to 12 days interval. Difficulty in getting skilled harvester has been a real issue that demands effective solutions. Manual harvesting using a sickle or chisel can only produce an average of 1 ton FFB per worker per day. Zirafa, introduced since 1990s to replace the cumbersome bamboo pole. High-reach pole introduced in 2002 to handling in tall palm harvesting. Next is all palm motorized cutter, which is cantas, introduced in 2007. Suitable for harvesting FFB from palms up to 5 harvesting height and was able to increase harvesting productivity by more than double. Cantas benefit the smallholder, individual harvester, contractor, and estate in terms of increasing productivity and income, and reducing workers and operational costs. Cantas is a motorized cutter specifically designed for harvesting FFB and cutting fronts. It is powered by a small petrol engine and utilizes either a specially designed sickle or chisel as the cutting knife. MPOB is the technology owner with the patent filed in Malaysia, Indonesia, Thailand, Brazil, Costa Rica, and Colombia. Okay, on the journal problem statement, cantas has been chosen as one of the projects under the Malaysian Economic Transformation Program (ETP) as a means to increase workers' productivity and reduce requirement of workers in all palm plantation. Since its introduction, MPOB received positive and negative feedbacks from the user. Positive side, majority agree that cantas can help to speed up harvesting operation, increase harvesting productivity, and reduce workers' requirement. The weaknesses, frequent breakdown, especially the cutting head, heavy and high vibration. All issues had caused cantas to be less favorable, causing decline in sales since 2012. So the main objective of this journal is high quality and durable, less breakdown with repair cost of below Rm 1 ringgit per ton per FFB, generating vibration of below 2.5 ms according to the ISO 53489 standard, having the specific weight of below 1.5 kilo. So the study locations of this journal, the field trial is a long-term evaluation conducted in commercial plantation to assess the machine performance and repair costs. The trial was carried out in Boston Kuala Muda Estate in Baling, Kedah, Malaysia, which is the same place where the benchmark data on previous version cantas was taken. Okay, next is material and method. Okay, design. The new design of the prototype is focuses at solving the three main issues: frequent breakdown, especially the cutting head, heavy weight, and high vibration. The specification of the previous version of cantas and the design of the new version are shown in Figure 1. Four main components were involved in the improvement: the cutting head, main pole, shaft guider, and engine. This is a Figure 1, proposed specifications of the new design motorized cutter. So this is the cutting head, pole, and the engine. So the cutting head, the old specification, offset, single bearing, stroke 10 mm, while the new specification, inline, double bearing, stroke 6 mm. I will discuss after this. The main pole or specification using the aluminum alloy, and the new specification use the composite carbon fiber. Shaft guider or specification, single bearing, and the new specification with using the double bearing. So for the engine, all specification using China engine at 3.8 kilo, and the new specification use Genoa Japan engine at 3 kilo only. Okay, this is the thing that they do for improvement of the cutting head and vibration reduction. So cutting head design. The cutting head must be strong and robust to overcome the toughness of the oil palm fronds and fruit stalk and to withstand the rough handling by the harvester. High-speed movement causes severe wear and tear on the moving parts, especially on the component which rub against each other. Rough handling by the operators is another factor that can cause machine breakdown. Cutting head design. In the new design, several elements have been considered as follows: the use of double bearing system on both sides of the main gear. This will improve stability of the gear. I will show you later. A single bearing system, as in the old design, only provide one side support to the main gear, which causes the gear running off during the rough harvesting operation. To have an inline cutting force that generates low vibration compared to the old design, offset cutting line as in the old design will generate higher vibration compared to inline. Cutting action as proposed in the new design. To shorten the distance of stroke from 10 am to 6 am, this can lower the magnitude of vibration of the machine during operation. Changing of material from cast iron into high quality metal to improve strength on certain components, especially the connecting rod. Okay, this one is the previous version design with one bearing and the new design with double-sided bearing. Okay, this one is one side bearing and then they put double side bearing. Okay, this one is previous version design with offset cutting action and the new design with straight cutting action. Okay, this is the design. And then this is the displacement of all design and the new design. This old design is almost 10 mm. And then the new design is only for 6 mm. They reduce it. So next is shaft guider. Shaft guider are placed inside the main pole to hold and guide the shaft to rotate smoothly to transfer rotational power to the cutting head efficiently. The unbalanced shaft rotation will generate high vibration that will be transferred to the pole. The previous version of cantas employs a single-sided bearing on the shaft guider that generate high vibration during rotating. In the new design, two side bearings are installed on the shaft guider that provides better and steadier stability on the shaft that reduce vibration during rotation. This is the old and new design of shaft guider. From the top view, new and old. The bottom view, old, don't have any bearing, and then this the new bottom view. So to reduce weight reduction, they design amendment on the pole design. The pole has been designed to have an oval shape as to increase the face contact area that provide a firm hand gripping during handling. The cross-section dimension is shown in figure 6. The oval shape will increase the stiffness on the y-axis, where it is very crucial in the lifting operation to ensure the pole does not bend excessively. The ratio of y to x-axis is 1.14. In the new design, the shape remains, but the material is changed into composite material, carbon fiber, which is about 20% lighter compared to aluminum alloy grade 6061 as used in the previous version. This is a cross-section dimension of the pole. So then next is engine. The previous version of cantas were powered by a two-stroke petrol engine with the horsepower of between 1.3 to 1.5 horsepower. Various models of engine were mostly imported from Germany, Japan, USA, China, and Sweden. The weight of the engine ranged from 3 to 3.8 kg. The new design, however, a small size engine, 1.1 horsepower, with a maximum RPM of 11,000 is used with a weight of 3 kg only. With the engine, the weight is reduced by 21%. Weight and reach. The weight of cantas is proportionate to its length. The weight gets heavier when the length is increased. For cantas to be effective, the specific weight should remain low, but the stiffness should be set higher. High stiffness will reduce pole deflection, where the combination of high stiffness and low weight can craft the pole to be made longer for higher harvesting reach. Several approaches have been identified to reduce weight. Using a lighter but stronger material such as aircraft aluminum grade alloy, composite as well as polymer material. to reverse and re-engineering of several components such as the cutting head, pole and transmission system, and having a lighter engine but the equivalent power. Okay, next is prototype of Cantas Evo. The new prototype, the new generation Cantas is shown. The new version is called Cantas Evo. Okay. Okay, this is a testing and data analyzing. The Cantas Evo will testing in the quality test. Then the quality test was conducted to ensure the prototype meets the quality standard. The machine has to go through and must pass the following quality tests prior to field test, final specification and mass production for commercialization. So they have few tests. First is physical test. Physical test include the machine total length, weight and its specific weight. Okay, number 2, functional test. Functional test is the test to verify whether the machine can do the job as it was designed for. The machine was tested to cut at least 10 oil pump front with the cutting time recorded. It must be able to cut a front smoothly without much problem. In the drop test, the machine was dropped from different height and angles, free fall, to see whether the machine or sample can stand the impact of the falling. The height were set 1 and 2 meter with the 3 different dropping angles, 30, 45 and 16 degree. And last is vibration test. Vibration test was carried out to measure the magnitude of vibration transfer to the hand of the user. Vibration level was measured at 2 points, at the engine throttle point and at the hand gripping point. The point where the harvester hold the pole during harvesting. So this one is point 1 and this one is for point 2, the harvester grab the pole. Okay, result and conclusion for the quality test. The physical test conducted shows that the specific weight of Cantas Evo is 1.45 kilo compared to 2.11 kilos for previous version of Cantas, proving that Cantas Evo is lighter by 31%, 31.3%. The functional test, a total of 23 fronts of 10 FFV were cut from 10 pumps. It was witnesses that the machine was easy to handle, easy to perform cutting operation, and the sickle was sharp. Drop test, experiment carried out proved that the machine was tough with no break, dent or malfunction on any parts of the machine. Vibration test for Cantas Evo, the vibration level at 0.1 and 2.2 were 0.6 and 0.4 respectively, while for the previous version of Cantas, the vibration levels at 0.1 and 0.2 were 9.8 and 10.2. Therefore, the vibration levels of previous version of Cantas were above the EAE value 2.5. ISO 5348 mechanical vibration measure and evaluation of human exposure to hand transmitted vibration. The test has proven that Cantas Evo is safe to be used in a period of 10 hours working a day. Engine performance test. The engine used was a Japanese-made engine, Zenwa brand. The test conducted showed that the maximum horsepower achieved was 1.1 horsepower at 8,600 RPM. while the maximum torque was 1.3 at 5,700 RPM. The engine temperature ranged from 90 Celsius to 114 Celsius, which is a normal temperature as recommended. Fuel consumption at 0.32 liter per hour with a total cycles of 5,066 cycle run in 20 days or about 550 cycles per hour. Okay, this is a summary of result of the quality test of Cantas Evo. Okay, the functional test passed, able to cut front without problem, drop test passed, and etc. So this is my reference and the acknowledgement. Okay, I would like to express my deepest gratitude to my lecturer, Dr. Ahmad Suhaili Maksu, for your knowledge and expertise shared with me. I am also grateful to my classmate help, last night feedback, session, and moral support. Lastly, I'm also thankful to my family, especially my parents, spouse, and my child. Their belief in me has kept my spirit and motivation high during this process. Thank you very much. Assalamualaikum.